Hello everyone, and welcome to our Offsite Fundamentals webinar. Thank you for joining us today, and I hope you're looking forward to it. My name's Imogen, and I'm a sustainability consultant at Action Sustainability and the Supply Chain Sustainability School. We're joined today by Ken Davey, who I'll be handing over to shortly. But just a bit of advice. If you have any technical difficulties, the first port of call is to log off and rejoin us. And if that doesn't work, then we do have dial-in options for you to call in on the number displayed, and you'll need to enter the participant PIN as well. So during the webinar, you'll hopefully have lots of questions, so please drop them into the question box on the right-hand side of your screen. We'll pick up a couple that you may have at the end of each section, but the bulk of the questions will be in the Q&A session at the end. The session will be recorded and made available in the Offsite resource library, so you'll be able to come back to it if you wish. So I'd like to introduce Ken, who is a registered architect with almost 40 years in the profession. His first involvement with Offsite was in the early 90s on various Ministry of Defence projects. He was lead architect on the Scottish Prison Service house block modernisation programme, with new blocks prefabricated using two different methods of construction. Between 2014 and 2018, he was head of Offsite and modern methods of construction research, part of an innovation cell for a tier 1 contractor that is no longer in business. Ken has been working with the Supply Chain Sustainability School to develop training material about Offsite and MMC for architects and designers. So without further ado, I'll hand over to Ken.
Thanks, Imogen. Good afternoon, everyone. Brief agenda for this afternoon. A few words about the current situation by way of an introduction, and then a section on construction industrialisation, a few examples of offsite in practice, good quality design, a session on the MMC definition framework, a recap and some thoughts to take away, and as Imogen said, towards the last half hour, if you're staying on for the full 90 minutes, is a Q&A session. So starting with the introduction, I think the case for Offsite and MMC is well and truly established. I think there's no need to try and actually establish anything further by way of this webinar. These are just a few examples of the multitude of reports that have been done over the past few years, one of which we will have a look at it in more detail on the bottom right. MMC is by no means a new term. The UK House of Commons set up the MMC committee in the 1920s, and MMC was adopted on a massive scale just after World War II to tackle housing shortage. So nothing new there then, as it were. A very early example of prefabricated timber system was actually used in the Forbidden City in Beijing in the 15th century, where the timber frames were actually prefabricated off-site into a system that actually locks together without the need for nails, and they managed to build the entire development in 3 years, which was quite an achievement at that time. So, as I said, the case is certainly well and truly proven. What we have is some background on the actual benefits of Offsite itself. The delivery process from start to finish is actually faster than for traditional construction. You can achieve far better quality and consistency through factory production. The average building site sends something like 30 to 35% of materials to landfill, whereas an average factory only sends around 5 to 10%. Working conditions in factories are obviously far safer, and even by adopting an offsite methodology, there are fewer people on site, and therefore building sites themselves should actually be safer environments. Productivity currently on construction sites is running somewhere between 35 and 40%, whereas the average factory, again, is about 85%, and the better ones probably 95%. Probably places like Nissan and Sunderland on the car production line. You can reduce the disruption to local communities by adopting an offsite methodology. There are construction techniques which are quieter, create less dust, reduce the number of vehicle movements. As one of the key things and objections to local developments tends to be the amount of disruption that's likely to be caused by the actual construction operations themselves. In terms of cost effectiveness, the offsite solutions and MMC may not be cheaper, as it were, but they can be cost effective in certain circumstances, such as having buildings completed faster such that clients can actually start to earn revenue, receive rent. And in terms of carbon reduction, well, I've already mentioned the reduction in site deliveries, but some of the materials such as mass engineered timber can actually reduce the carbon footprint of our development quite significantly. So the combination of offsite factors can actually help all round in terms of how we improve the way we build and reduce our carbon footprint. Just a reminder, obviously the Construction 2025 targets published by the government in 2013. You could probably understand the cost programme in carbon. In terms of the exports, Britain is recognised as being a leader in terms of digital technology and some of the other research that's we do. Although the construction industry is criticised for not doing a great deal, I think there's a bit more than people realise, and that would obviously help drive up exports. And then, as the benefits I've described in the previous slide, obviously can help us address the carbon cost in the programme targets. One of the inhibitors, which I see in terms of limiting the amount of offsite and MMC that is actually implemented, is the fractious nature of the construction industry. And this is an image which I use to represent that. And you can actually see this at different levels. You can view this as architects, engineers, quantity surveyors buzzing around clients and trying to get on a tender list, or you can take it down a level or into the next stage, and you can look at it as subcontractors, suppliers, obviously trying to get onto a tender list with a major contractor. I think what we need to do is think about different contractual models, and there are initiatives already underway in this respect. In the past, we've had frameworks and alliances, we've had project partnering contracts. The MOD has tried prime contracting. We've had NEC with collaboration, and we've had single sourcing. Well, however, that makes people a little bit nervous when it comes to the competitive marketplace. The Construction Leadership Council is currently looking at integrated project alliancing, which encourages more teamwork, or better teamwork, and more collaboration. So I think we need a step change in the way that the industry is organised and the way that contracts are actually administered. So that's by way of a brief introduction. What I'd like to do now is launch into part one. As you can see, construction industrialisation. I will tend to use the terms offsite, MMC, and construction industrialisation. Essentially, they mean the same thing. It's an iteration of the challenges which actually face the industry is to understand the process, the MMC stroke DFMA process. Through knowledge, we need to try and introduce more standardization to realize the benefits of offsite and MMC, which is the purpose of today's webinar to a certain extent. We need to stop designing prototypes every time. We should be trying to use common platforms and incorporating standard components, which need not compromise creativity. If anything, by using standardized components, architects, designers could actually spend more time on the important parts of a development rather than the mundane. The key words in this particular image are actually the last two where possible, because effectively offsite and MMC are simply not appropriate for every project. But I will later in the session actually demonstrate how there are building types now which are actually adopting some sort of MMC approach, which you may be surprised by. What I'm going to do is go through design for manufacture and assembly in a bit more detail relative to the RIBA plan of works, and then look at the other four headings and throwing in the other considerations. So The bullet points are actually the 5 stages, the 5 basic construction industrialisation stages, and I've tacked on a few other things to think about at the end of this particular section. Just a reminder of the fractious nature of the construction industry. Digitally enabled construction is a key driver for Offsite and MMC. It's getting designers to understand to a certain extent at a basic level that what they have actually designed can be manufactured. Have they actually thought about manufacturing tolerances? Have they thought about the manufacturing process? Have they made what they've designed simple and easy to assemble on site? The Japanese have a term called poka-yoke, which is intended to be foolproof assembly. And examples of that are the plugs on electrical cables. At a basic level, a 13-amp plug is designed such that it can only go into a power socket in one particular way. And I'm sure on construction sites we've got the same with the IP-rated cabling. The plugs can only fit one way, so they're actually foolproof. And that simple philosophy can be applied to design in terms of how interfaces are achieved such that they can only be made in one particular way. So looking at the RIBA plan of work and design for manufacture in particular, you may think that before you even have a project that there's nothing to do. However, this is the ideal time to start speaking about MMC and Offsite to your clients and trying to get some sort of commitment. It would also be a good time to actually think about defining the strategy, fixing the strategy perhaps even, and also thinking about what the benefits and opportunities might be for a particular development, even if it's just an initial thought as to, I need this type of building from a client. Particularly important in certain types of development when it comes to accommodation, where there's lots of repetition, whether it be high-rise residential or hotels or any other types of building where standard components can be used time and time again, either stacking in one particular building or in repeat developments around the country. The preparation and brief, it's pretty much similar to what you would be doing at strategic definition stage. You may want to then think about risk mitigation, and that risk mitigation could be health and safety, it could be time and duration, it could be delivery risks, it could actually be commercial risk. And every aspect of MMC and Offsite has the potential to actually help mitigate risk across a whole range of things on a project. I think preparation and brief stage, once you are aware of the building type, you should actually be looking at opportunities and challenges of adopting a particular system or particular products or assemblies in terms of Offsite. At this stage, I think speaking to clients, designers, and potentially a wider integrated project team, you would really want to see an open-minded acceptance and agreement to proceed with an MMC strategy. Some sort of recognition of the potential opportunities and benefits of MMC, and a commitment from the team members to actually pursue that strategy rather than sitting on the fence and saying, no, it's not for me. Concept design, in some people's opinion, this is the most important stage. It's understanding the full potential of MMC and Offsite, whilst the design is being developed, considering the pros and cons of different construction strategies and systems and components, and working from the preparation and brief stage into a more detailed assessment of the benefits and opportunities and challenges, and identifying possibilities. You could say, what does good look like for Offsite and MMC at this stage of a project? It could be standardization and repetition has been maximized without inhibiting creativity. It could be a design focus on bespoke elements, maximizing the use of platform design and standardized components, in which case you're looking at the adapters as how to these components will interface, and how you might accessorize them or dress them up so they actually look nice from a town planner perspective. And underlining all of this is the ability to streamline the design process, as you're not having to, designers are not having to design every single component. I think more manufacturers and suppliers are beginning to realize that if they can provide, obviously, BIM models of standard components, which are interchangeable through different building systems, there's a great benefit, and the designers can actually pick those up and incorporate them into BIM models, Revit models, without having to think too much about them. Spatial coordination, by this stage, if you're not thinking MMC, you're making life much more difficult for yourself. And certainly some architects, designers believe that this is the critical stage rather than concept design. You should certainly by this stage be looking at solutions that minimize risk and increase certainty of delivery. It's probably the last opportunity for MMC to have a major impact on the design and construction strategy. By the time we reach technical design, it's too late. You could have gone through stages 1 to 3 on the basis of an MMC offsite strategy. You could have identified the potential solutions. You could revert at this stage to true traditional construction. You could find at this point that there's lack of market capacity in terms of the type of product, the type of assemblies that you actually require to fulfill the philosophy, the strategy that actually you've set out. However, you cannot reverse that. You cannot go through stages 1, 2, and 3 on the basis of traditional, and then suddenly decide at stage 4 that you want to revert or change to offsite and MMC. It's quite common that modular building manufacturers are approached at this stage of a project to get and asked to provide a cost comparison with traditional construction. Well, in order to do that, they would have to probably redesign the building, and the only thing that's likely to do is to slow the development and increase the duration, potentially increase the cost, and just cause disruption. So by this stage, it's too late. So you're locked into an MMC offsite philosophy in terms of the manufacturing and construction. I think one of the key things you'll find is that design freeze comes much earlier than in the process compared with traditional construction. If it's a full volumetric modular solution, obviously the manufacturer needs drawings signed off before actually placing orders and before the manufacturing process starts, which isn't always the case on traditional construction. And then as a design team will find that they may have to do things concurrently rather than consecutively, simply because of that early design freeze. And carrying on into the actual construction assembly, provided everything has been considered in advance, there should be no logistics issues. You should have already considered assembly, how the building is going to be assembled on site. The manufacturing and construction program has a far higher degree of certainty because quite a bit of the manufacturing is being done in controlled conditions off-site, which aren't subject to the vagaries of weather. As I've said previously, that the actual workforce on site is much reduced, therefore the accident frequency rate should actually be reduced as well. And then from a management of the actual construction process itself, because a lot of the preparation has been done for manufacture, site queries are significantly reduced. Therefore, the site time on chasing the designers for responses and the designers having to respond, they're all reduced by thinking in advance and actually having things fixed far sooner than it would normally be in a traditional construction. when it comes to handover and closeout, it's probably down to getting the right information to the client. It's making sure that the final federated BIM model is ready to be transferred and is understood by the client and the end users and the people who are going to maintain and operate the buildings, developments. I mean, ideally, at this stage, you would progress into a simple and quick handover process, and you're handing over a project on time, to budget, to the right quality, and with no legacy issues. And then finally, in use, it's actually checking the performance. Has everything that has been designed and built actually achieving the performance that was intended? I'm not entirely sure how many post-occupation evaluations are actually completed. It's stated in the soft handovers, I think, from memory. But as with previous stages, very much of what's done in use will depend on the actual commission, whether it be as a designer or as a contractor or as a supplier, just what you're actually contracted to supply during this phase of the contract. So that's DFMA and the RIBA plan of work. The next stage is actually offsite manufacturing. So the things to this course is obviously written in terms of are focused on architects and designers, and you could ask the question, what does a designer need to know about offsite manufacturing from a fundamental perspective? Timescales are critical. I've mentioned design freeze and fabrication drawings and having basically fabrication drawings signed off before any manufacturing commences. Product availability, is there sufficient capacity in the marketplace? Is there adequate capacity even within the suppliers that you're looking at? If you think about the recently or almost complete 40-story tower block in Croydon, which required a huge number of volumetric modules, is how many manufacturers can actually produce enough to keep the site assembly process running to schedule. There are quite a few obviously having to be stockpiled before they're taken to site. There are something of the order of 50 volumetric modular suppliers around the UK with obviously varying degrees of capability. And in the wider marketplace, obviously, Europe and the world in terms of what's available by way of assemblies and components. There was one scheme I worked on in Battersea. The bathroom pods had to be imported from Belgium simply because the UK markets didn't have the capacity to actually supply. And then during the offsite manufacturing, we also need to think about lead-in periods, ordering goods and materials for the actual offsite manufacture, and then lead-in periods for delivery to site of completed components and assemblies. And at this stage, offsite information format, does what the designers produce by way of a Revit model actually interface with what the manufacturer requires to produce the finished goods? And logistics, again, what do we need to know about logistics when it comes to offsite and MMC? An abnormal load is anything which weighs more than 44 tons, is wider than 2.9 meters, and is longer than 18.65 meters. Motorway bridge height is 4.8 meters, so obviously height is restricted. The 2.9 meter width needs to be, anything above the 2.9 meter width needs to be escorted. Routes for extra wide loads obviously have to be approved by the authorities. And that 4.8 meter bridge height on the motorways is severely limited once trucks are off the main motorway network and the A road network, where it could be, it's not just the bridge heights, but it's the load capacities of the bridges as well. And then there are time limitations. I think in Greater London that deliveries are banned between 6 a.m. and 10 a.m. and again between 3:30 and 8 p.m. Monday to Friday. And in the central London, I think major deliveries can only occur between 1 a.m. and 5 a.m. in the morning. So all these factors have a bearing on the logistics. On-site assembly. Does the crane have enough capacity? Is there enough hook time on the crane? Is there sufficient space to get the vehicles with large loads onto site? Is there actually set-down space, sufficient set-down space? Can testing and commissioning be completed off-site to minimise the on-site operations? Lots of little things that come together need to be taken into account in the wider collaborative team effort in assessing the benefits of MMC and off-site and how they're going to be realised. Maintenance operation. I have been involved in a project where the maintenance team were actually involved with the design of the facility and actually had some degree of influence over the specification. Obviously, starting to use common platforms and components means that a stock holding for maintenance can actually be reduced or a planned maintenance. In one particular contract, I was involved in the maintenance team actually specified the type and number of light fittings that could be specified on a project such that they were actually held in stock rather than having to increase the numbers. I think at this stage, the through-life operational costs, certainly, if they haven't been considered, they must be considered as part of the overall construction industrialisation process. I'm speaking as if this is a consecutive process, but in theory, all of these things need to be taken into account during the earlier design stages before manufacturing and construction actually starts. Other considerations. Where does the professional indemnity assurance cover stop in relation to design, manufacturing and prefabrication? Who's responsible? I don't have an answer at the moment. Are there any public liability issues? Are different types of insurance required for design, for manufacture and assembly? Who takes design by liability? Who has the intellectual property rights for freshly designed components and assemblies? How do we go about getting warranties? We do basically now have the NHBC accepted system status for housing design. We've got the build offsite property assurance scheme for modular construction, and we've got the BRE Building Performance Standard 7014. Obviously then, as the standards are beginning to develop, it's becoming, and Offsite and MMC are becoming more common, that the mortgage lenders and the finances are actually accepting that they can insure them with some degree of confidence. And then I've touched on it already, collaboration and alliancing. As DFMA and MMC gain momentum, there has to be more collaboration across the industry to actually make it work. That's the end of part one. Take a quick break and allow Imogen just to see if there's any questions.
Thanks for that section, Ken. We don't actually have any questions at the minute, so just a reminder to just pop any questions that you may have in the box in the bottom right-hand corner of your screen, and we'll answer them when we can.
Okay, thank you. Right, offsite and practice. Split this up into three sections. First one is residential, next one is non-residential, and the final one is infrastructure. Just run through a few projects, starting in the residential sector. This is a volumetric modular accommodation block in London with a very nice terracotta facade. The facade was designed in collaboration with a ceramicist, and the point I'd like to make on this particular project is that volumetric modular regular Lego blocks need not look volumetric modular on the outside. I've used the term already. You can accessorize, you can dress up the building, you can make the exterior fit in with its surroundings. This is Dalston Works. When it was completed, it was the highest, tallest cross-laminated timber building in the world at 10 stories high. Sorry, I'm running two presentations here, and for some reason I had the wrong notes, but never mind. Right, we're up to date. So cross-laminated timber structure is about 30% lighter than an equivalent steel or concrete frame, and because of the foundation challenges with this particular development, i.e. limited piling capacity, and on the line of HS2, the actual the dead load of the building had to be considered in some detail. But by going with cross-laminated timber, the designers were able to add in 15 more apartments in comparison with a concrete or steel frame solution. And for the developer, that meant, on average, another 15 times 400,000. So the construction methodology can certainly have a big impact on the profitability for clients and the commercial potential of a scheme. The downside in this particular instance is you can no longer build this type of development following the Grenfell disaster, because the use of timber above 18 metres is forbidden. And that's despite the fact that cross-laminated timber chars. And recent research by Cambridge University have established that it self-extinguishes. And this is where a blanket ban on a material isn't perhaps correct. A development by Urban Splash in Manchester, modular accommodation for housing, which has a flexibility for customers with open plan options, cellular options, and upside down options. So the living room and kitchen on the top floor, and the bedrooms on the ground floor. There's a bit of potential disruption with one of Japan's biggest house builders actually taking a share in Urban Splash, which hasn't had a major impact to date, but probably will have a growing influence. This is the Y Cube in South London. It was actually financed by the YMCA. The modules here are single occupancy flats, 26 square metres. The dry construction, to the extent that no water was required on site and no scaffolding was required on site, which obviously has a big bearing when it comes to safety, health and safety, and also from an environmental perspective. And the construction standards are such that the estimated heating bills are running at something the order of 80% lower than traditional construction of similar accommodation. And as I said, the use of modern methods of construction and standardization need not inhibit creativity. Obviously, the Michael Rich's Goldsmith Street in Norwich, which actually won the Stirling Award in 2019. And a bit of experimentation with Lego blocks by Wilkinson Eyre for the Dyson campus in the West Country. These modules are about 30 square meters each, which is slightly more than the Y Cube. The Y Cube was 26 square meters per module. And in this case, the exterior cladding is aluminium, and the cross-laminated timber is left exposed as the internal finish. And then finally, in the residential areas, this is an R house in the Scottish Highlands. It's a combination of conversion or extension, and the extended part of the house is actually closed panel construction with roof cassettes. Some parts of the country suffer labour shortages more so than others, and the vagaries of the weather conditions in this part of the country, in the Scottish West Coast, mean that fast construction is of significant benefit. If anyone's interested, if you Google R house, you can actually look at the different projects that they can achieve. There's a basic R house which sells for I think it's 100,000 for an R1, but there are variations in that. It's either 100 or 120,000. And there is a little video which you can actually watch on Vimeo, which actually shows the construction with the use of the panels and the roof cassettes. So moving on, non-residential. Vitso factory, Leamington Spa, single production and office facility, which is 135 metres long and 25 metres wide by 6 metres high at its lowest point. That's excluding the roof lights. Cross-laminated timber, wall panels, modular roof lights and window system, some additional steel for stiffening. The whole building was actually assembled, I should say, in 23 days, and it's been designed as such that it can be easily extended. Nice hotel, very, very close to the Tower of London, and on the edge of a obviously UNESCO World Heritage Site. The original building before the hotel was rebuilt was 6 stories. By using modular approach, this was increased to 9 stories, and you can obviously tell from that there are significantly more bedrooms in the hotel than there would have been at 6 stories, with a major increase in potential revenue. The exterior includes granite panels in some areas to mirror some of the buildings in the surrounding area. The cheese grater. The X steel sections you can actually see on the image on the side of the tower were prefabricated off-site in 7 stories at 28-meter high sections, and assembled on site. Being in the city, of course, severe restrictions on access for deliveries. More than 80% of the components for this particular building were assembled in the East Midlands. Technique in terms of just-in-time delivery, which again is nothing new. The Empire State Building was built in 13 months from March 1930 through to March, April 1931 by prefabricating the steel components off-site and actually delivering them into the centre of Manhattan. Obviously, a series of trucks just-in-time delivery, limited to, I think it was 2 minutes for each delivery. Project Capella, biosearch laboratory would normally be built using in situ concrete because of the vibration constraints. Kier Construction were engaged at RIBA stage 1, and they brought in a specialist precast contractor to look at the construction options, and through this collaboration and teamwork they reverted to a precast solution, which wouldn't have been possible if the architects and engineers had simply designed this on the basis of in situ concrete and taken it through to stage 3-4 without actually speaking to the supply chain and the specialist contractors. So by coming together as a team, they obviously benefited from the knowledge of everyone involved, and the collaboration delivered something different. Bit of decoration applied over the facade of Birmingham Central Library. So the aluminium rings were fabricated locally, a reflection of some of the trade capability in Birmingham, and then clipped onto the unitized panels. University building in London. This is actually a modular building prefabricated by Portakabin. The 8,700 square meters was built in 12 months on site, which is estimated to have taken 50% of the time that it would have done for a traditional construction. A grounds maintenance equipment store in the west of England for Hereford and Herefordshire and Ludlow College. Very, very tight financial constraints. The budget was £1,500 a square metre, including the specialist maintenance equipment such as exhaust extract. Design team chose cross-laminated timber panels, columns and beams, and actually achieved the end result within the budget, including the M&E equipment. And one of the interesting things about using a timber substrate is that the M&E fixing are simple wood screws. So no drilling and plugging requires, just straightforward into the timber. Some quick examples on offsite infrastructure. Slightly different technique for this one. It's not so much prefabricated components. The steel erector, MEP contractor and cladding contractor collaborated to construct a 54-metre long prototype section of canopy, station canopy, off-site. And then they dismantled it, but they didn't take it to site. They actually reassembled it such that they addressed any of the issues that they had when they first assembled it. London Bridge is the 4th busiest station in London, and only 2 platforms could be released at one time. So the team wanted to make sure that they didn't have to address glitches and issues when they were trying to actually work to a very tight schedule in a live station. Very recently completed major infrastructure in the UK, quite an interesting supply chain. 110 bridge deck units, each weighing 750 tons, were fabricated on the dockside in Shanghai by a company called the Zhenhua Port Machinery Company. The ZMPC are probably better known for the dockside cranes that they manufacture for unloading container ships. So 110 bridge deck units were then shipped all the way around the world, unloaded on the north bank of the river in Rosyth, where Shepherd Engineering Services fitted the MEP, and bridge deck concrete was added, and then they were actually floated out and lifted into position. A clear instance of global supply chain for offsite and prefabrication. And its near neighbour is probably an early example of offsite and MMC. Pop-up factories were set up on the south bank of the river to preform all of the steel sections. It is the first major steel structure in the UK. The curved sections were preformed, the holes were drilled for the rivets, and then the components were then transported out to site where the team could actually then rivet them together. So a bit of pre-thinking and off-site manufacture in a slightly different format. An innovative project in another respect, and they actually had a welfare fund for the workers in the event of accidents and illnesses. Very early example. And then finally in this section, an extension at Dublin Airport, completed by McAvoy, prefabricated passenger boarding zone. Critical things on an airport, certainly on the live side, the air side, is foreign object damage. And by adopting a modular approach to this, there were 2 major benefits. One was the speed to get the building up and completed and operational as soon as possible, such that the airport would get revenue as soon as possible. And obviously then to prevent the possibility of waste materials actually being blown onto the airside and causing severe disruption. So just a quick reminder to finish this particular section off. Offsite can achieve greater certainty in build time and cost, improve quality, and better energy reduce and resources. Part 3.
We do actually have a question at this stage, Ken.
Yep.
So it's, what percentage of projects in the UK on average are modular or MMC? Also, what is the split between residential and commercial? And finally, what do you see as the main barrier to further increase in application? And how should the market overcome this?
As far as the the percentage is concerned, I think the percentage of offsite and MMC was reckoned to be between 7 and 8% last year. I can't remember what the actual market figures are. I really don't know of the metrics in terms of the split between residential and commercial. So that was two. What's the third one, Imogen? It's a three-part question.
Yep. So the second question was the split between residential and commercial. And the final question is, what do you see as the main barrier to further increase in application, and how should the market overcome this?
Two things: adoption of MMC, adoption of design for manufacturing, and the contractual model. It has to be collaboration. It has to be alliancing, teamwork, partnering. Far more interface between the designers and the manufacturers and the assemblers or constructors. I won't call them builders, constructors. Okay.
Great, thanks.
Does that cover everything?
Yeah, thank you.
Yeah, okay. Right. I don't know how many people listening in actually are aware of the definition framework, which was published last year. It's pretty much focused on residential. However, I think some of the terms that you'll find can be applied across the entire construction sector. I think I can understand why it's been done, because there's a big impetus to increase the number of residential and homes that are built in the UK. But I do think that it's missing a trick to a certain extent. So this is what it looks like. You can actually download a copy from the government website if you want to actually go and find it. It's a very, very long URL, so I haven't actually included on the actual slide. These are obviously the typology you can see on the left. Basically houses, but the material genres actually apply to virtually any form of construction, any building sector, any construction sector rather. And these are the categories. 1, 2, 3, and 5 are described as pre-manufacturing. 4 is additive manufacturing, and 6 and 7 are actually process-led production improvements. The whole idea of this framework is to give everybody a common language such that designers, manufacturers, constructors, lenders, insurers are all understand what they're speaking about because they're actually using that common language. Category 1, 3D primary structure is the definition. 3D primary structure is basically a box, a volumetric box or module. Interestingly, this definition, this category does not include pods and utility cupboards, which are designated under another category. Something that quite a few people don't appreciate is the difference between point loading and line loading for a volumetric module. Point loads on the left, hot rolled steel chassis with potentially cold rolled or timber infill, and then on the right, line loaded cold rolled steel module. An example of a volumetric module, probably at the extreme, as it will be the world's tallest building once it's finally complete. These are early photographs from George Street in Croydon. The structure has been topped out. I think it's being finished off inside at the moment. Residential accommodation directly across the street from East Croydon Station. I think that train line will get rather busy once things clear up in terms of the way we're behaving at the moment. Another example in London of volumetric modular. Thing to stress here is the transport conditions. Obviously, I mentioned earlier the definition of a wide load. Generally, modules tend to be up to about 3.7, 3.8 meters wide, a single bedroom flat into one module, and a two-bedroom apartment usually takes up to. The previous example I showed with a terracotta facade, it was actually 3 modules per flat, so it must be quite a generous development. This is described as a sectional building, obviously non-residential commercial space with the chassis, basically the hot rolled point loaded chassis used to create the space with varying degrees of finish. Some may have outside walls, some may have internal walls, but they're assembled obviously in the final solution to very quickly generate a volume which can then be fitted out internally on site. This is the sort of indicative timeline for the project that on the previous image, some indication of how volumetric modular can actually increase or reduce the overall duration. So we're looking at 32 weeks traditional and 14 weeks volumetric with a concurrence. And again, I spoke about concurrence in terms of activities, so you can see the 6+6 in the mobilization and the manufacturing period where there's concurrence. A couple of examples ongoing. Legal & General's cross-laminated timber house prototype. And in Singapore, concrete modules are used extensively for residential accommodation, not so much in the UK. I'm only aware of one UK building which was built using concrete modules. That's Celtic Manor Hotel. An Irish company produced the modules for that particular project. Category 2 is obviously flat pack or 2D systems. What we're looking at here is a closed panel system on the left and a SIPS structural insulated panel on the right. There are issues with the SIPS panels now in terms of height again because of their composition, which is effectively as a sterling board with an insulation core. Some other examples of the 2D category 2 2D system is light gauge steel prefabricated panels, cross-laminated timber used for a staircase, which is actually quite attractive. And in the closed panel system, I think that's actually in a factory in Glasgow for housing, where external, internal finish can be applied, the windows and doors, etc., everything fitted before going to site. And then going on to the next one is actually probably my favourite material. You probably get fed up me speaking about cross-laminated timber. This was a development by Mace near the Elephant and Castle, 8 stories. Material was actually imported from Austria, as the UK doesn't have the capability to actually manufacture. The timber is good enough. Napier University has actually tested the quality, and the materials are actually good enough, but there's no one in the UK currently manufacturing to the scale that could supply this type of building. There's a bit of castellation and almost like the old-fashioned mortise and tenon joints when the panels go together. And then when they are fixed, it's actually long wood screws. So again, much quieter than, say, concrete and steel, or certainly steel construction. And the floors are inherently stable, as you can see with the pods being loaded as the construction progresses. And you can do lots of things with cross-laminated timber. And extending again into the flat pack systems, this is an FB McCann Hotel in Manchester, where a unitised system is being built without the need for scaffolding. And then on the right, you can actually see a cross-wall system with the pods actually dropped into place again. The image on the right requires external finish, just a straightforward off the steel mould, flat pack concrete panels. And then a brief explanation of the cross-wall system flat pack panels on the left-hand side as to how the system actually goes together. And so the flat pack system keeps going on. This is another example of the light gauge steel panels. This is a student residences in Newcastle. Category 3, non-systemised. Architectural columns cast in the yard in Cheshire on the left, and then a prefabricated loft extension on the right, categorised as non-systemised structure. And other things coming into that are glue laminated timber. The B Sky B office building in West London is an interesting example of hybrid structure. Steel frame, cross-laminated timber floor panels, which are exposed on the underside, glue-lam beams for the roof structure, and pre-finished roof cassettes for the weatherproofing. And then a category 3 kit of parts is the residential tower in London, which was actually completed by Laing O'Rourke. Now, Laing O'Rourke have a target whereby they try to achieve certain figures, which is a 70-60-30. That's 70% manufactured off-site, 60% site labour reduction, and 30% faster compared with traditional concrete frame. And they actually achieved it for this particular project. And as I said earlier, there are some interesting things that are happening in prefabrication and MMC. And if you can build a cathedral adopting MMC techniques, you can build virtually anything. Arabs have been assisting the team in Barcelona to develop a pre-stressed wall module for the towers on the Sagrada Familia. This table is an analysis of some of the different systems across certainly structural systems. I won't dwell on it, and I wouldn't expect you to actually read that, but it is available to download, I think, from the website. If that version isn't available at the moment, we'll certainly make it available. And then we go into category 5. A couple of examples is the cross-rail tunnel linings on the left, and a little lintel assembly from IG, which is manufactured obviously off-site and interesting and clipped into place. And the bricklayers turn them upside down, such that they can point the bricks on the bench, and they don't actually have to crane their necks and potentially cause injury when they're actually trying to do above their head on site once the lintels actually in place. So I think the point here is that it need not be 3D modular to be off-site or to be MMC. There are lots of little things that can be used, assemblies, products. One of the most common things in residential accommodation is certainly high-rise is the utility cupboard. And in this case, these cupboards were actually manufactured for the Battersea redevelopment on the south bank of the Thames. And you can see the metrics there, 11 activities on site reduced to 1. And within the controlled environment, there's no clash of trades. There's no plumbers climbing over heating engineers, climbing over electricians trying to get into the one small space in the apartment. So quite significant benefits in that case. MEP versions, obviously, modularized plant room, rooftop plant room. And again, we're in the non-systemized, is basically a unitized cladding panel with the windows already fitted. And other examples, as I said earlier, these are 3D structures, but they're not classed as category 1, they're category 5 in terms of the framework. An illustration of a combined shower room and kitchen on the left. A concrete bathroom pod in the centre, which is quite unusual, and then the detailed design. And the point I would make to architects, don't draw the pods or the layouts to the nth detail. Tell your pod manufacturer what the constraints are by way of width, length, height, and let them do the detailed drawings and construction spec for you. So you can just include that as a component. And long span roof cassettes and obviously cladding panels, still part of all category 5. MEP assemblies, service risers, sectional plant rooms, and even down to the smaller scale prefabricated valve assemblies. And then the horizontal service modules. I think NG Bailey installed something of the order of 1.5 kilometres in one project in Aberdeen, which actually then reduced site labour by something in the order of 60 to 65%. Additive manufacturing category 4, essentially 3D printing. An interesting example in Holland, actually, the stainless steel bridge. I'm actually trying to find some photographs of that installed. but everything it seems to come up is still that not that particular image, but they have load tested it by having people walk across it in its current location. And in category 6, labour reduction, productivity improvements, a story height block from H&H on the left, and then a dry screed board on the right, which is obviously much faster to install than a wet cement screed, and also uses a fraction of the water content. So not just productivity improvements, but obviously environmental potential as well. And as productivity, again, small scale stuff. This is a prefabricated arch for a development, Chelsea Harbour. And then finally, category 7, productivity and assurance improvements. We've got drones, we've got HoloLens. Obviously, the application of technology has a potential to have a massive impact on the construction industry. I think we're only dipping our toe in the water at the moment in terms of what we're actually using. Obviously, visual augmentation, physical augmentation with exoskeletons, goodness knows what else in terms of the technology that could be obviously employed. And then finally, in this section, this is Sam. This is a semi-automatic mason, and you can actually check him out on YouTube. If you just actually Google Sam, I think. And that's the end of our session on the framework.
That's great. Thanks, Ken. I think if you want to give the recap and then see if there's any questions.
I'll hand it over to you. Yeah. Okay. Brief recap, everyone. Benefits of Offsite. Obviously, we've got the program benefits. Timelines are shorter. We've got the value. So the use of standardized components and platform design has the potential to improve value because you're not having to redesign them all the time, rethink them. Productivity, because an average factory is 85% compared to 35 to 40 on a building site. Working in controlled environments with fewer construction or assembly personnel required. Designed in the computer, virtual design, and then prototyped once it's actually been designed. And I know I've used prototypes earlier and saying not to design prototypes, but test and agree quality and standard offsite. And obviously there's less waste, better opportunity for recycling if it's done in a factory, and with a higher building standard, better air tightness, then reduced carbon emissions. And in response really to one of the earlier questions, what we need to do is leverage the behaviour to see a greater uptake. So we need to make it easier. So it should not be a challenge. It should become second nature. We need to eliminate ignorance about the potential and the systems and actually spread the gospel, as it were, about Offsite and MMC. It should be mainstream and normal instead of peripheral and the exception, to make it more social. And to make it more desirable, we need to spread the word in terms of value and make it more attractive. As far as rewarding is concerned, it's satisfaction and achievement, and that satisfaction and achievement could be for individuals, for businesses, for clients, for end users, for anybody interfacing in the environment, which is virtually the whole population. And then finally, we need to make it habit, and if it's habit, it becomes second nature. That's it. Over to Imogen.
Thank you, Ken. Yep. Really informative. We'll come to some questions shortly. So whilst I tell you a bit about the school, if you could please drop any questions you have into the box and then we'll come back to them. So have a think whilst I'm just chatting through. So over this past year, the school, in collaboration with MTC, NOCN, and with funding from CITB, has been creating new off-site learning material for you to use. Some of you may even have already been on some of our pilot courses. So the material is focused on 6 different work streams and is made up of full-day courses that you can go on, as well as new e-learnings, videos, and exercises. The work streams are offsite design, offsite project management, procurement, quantity surveying and cost consultancy, logistics, and site management. They look at different sectors, residential, commercial, and infrastructure, and also look at different systems, timber, steel, concrete, and volumetric. So if this is of interest to you, keep your eyes peeled for when the new resources come onto the library. And we're also going to have 2 pilot courses for site management in the next couple of months, if that's also of interest to you. So the final thing I'd like to tell you about before we look at some questions is your offsite self-assessment. This is what you should do next to further your offsite fundamentals knowledge. So it's really easy. All you need to do is go onto the offsite page. You then scroll all the way down to the bottom, and on the left-hand side, you'll see a link to your offsite assessment. You then answer a few questions about where your knowledge is currently, and then you'll receive your bespoke action plan. So this shows you exactly what resources you should look at to further your current offsite knowledge. So hopefully that's given you a bit of an overview as to what you need to do in terms of self-assessment next. So now if we take a look at any questions that you may have. So one question we've got here, Ken, is what's your prediction of the future of modular building in the UK? Do you think it will get more popular in the upcoming years?
Yes, as a simple answer. I think once people understand the principles and the potential and the actual physical nature of the modular building, we will see more people adopting that particular approach and accepting it as a norm as opposed to an exception.
Okay, so the next question we have is where can we find this presentation? So I'll be emailing it out to you afterwards. And also this webinar will be recorded and will be in the Offsite resource library. So there'll be different ways that you can find the presentation. I don't know if there's any more questions that anyone might have about anything we've spoke about, or any case studies or just general offsite knowledge that you might have questions about. So we don't have any currently waiting. So I'll just give you a couple of minutes and see. Ken, is there anything else that you think any questions might have come up during that session, or anything that you think people should know, any takeaway key messages?
I think the key message here is that I've run through the content of part of the offsite course for designers, an abridged version. It goes into considerably more detail, and we would, if not, when we're not running webinars, if it's a workshop, then it would obviously there would be far more interaction, and we'd be running exercises as well. So this is a dipping the toe in the water to a certain extent. If you actually joined one of the courses, you would actually see a lot of what you've actually seen by way of images, but the extent of the explanation and the background information is far more extensive. We've obviously had to tailor this for an hour to an hour and a half, and I've run through probably 2 out of 5 or 6 modules from the design course, which are then repeated across some of the other parts of the training. So if this stimulates your interest, then look out for these follow-up courses in the next few weeks and months, subject to obviously social interaction being permitted sometime in the future.
Thanks, Ken. So the next question we have is, do you sense that the construction industry is ready to embrace change?
I think some parts of the construction industry are, and the expression is we have islands of excellence and a sea of mediocrity when it comes to offsite. But I think that there is an impetus for change, and you can see that if you go to, say, Kier and actually look at their approach and the Choice Factory adopting offsite and actually looking at it on a project by project basis. I haven't spoken to anyone from Skanska recently, but again, Skanska had adopted a philosophy whereby if they couldn't actually think off-site, then they simply didn't want to tender certain projects. So there is a drive at one level to see more adoption. I think it's more difficult perhaps at the SME level. And I think there are barriers in place, as I say. I think behaviours is a significant barrier. The contractual model that operates is a barrier simply because it doesn't encourage collaboration. There is a move in some sectors to go technology agnostic, i.e. have to platform designs and components assemblies that don't rely on one manufacturer, and they're not copyright, they're not IPR, and they are interchangeable. So if a client comes along and basically says, I'd like X, Y, and Z to this specification, any manufacturer or supplier can actually do that, rather than it being the other way, whereby the goods and services are manufactured and offered, so that they're not driven by demand in some cases. It's what people want to manufacture rather than what people want to buy.
Great. So the next question is, how do you see the future of the modular market, especially in the residential sector, bearing in mind the national shortage of housing in the UK?
The large housing companies are seriously engaging and adopting MMC. I think Barratt's are probably prime example whereby they're trialing different methods, and they have actually purchased their own timber frame manufacturer after working for quite a few years with Stuart Milne. It's interesting that 80% of the houses in Scotland are actually timber frame, and that construction process has been followed for years and years and years. In fact, Stuart Milne, who I've just mentioned, were one of the first companies to deploy a design and fabrication software tool, which allowed the designers to do the drawings up in the office for house kits and fire them straight at the machinery in the workshop to actually cut the timber and send the information down for the workforce to assemble the different elements of the house, prefabricate the panels, etc. So if Barratt's are actually doing that, we've then got Legal and General, who have been working on a factory near Leeds, Sherburn and Elmet, for several years to have an impact. We've got Swan Housing Association that invested in its own factory in the east of England, looking at cross-laminated timber initially, but the change in building regs have had an impact on that. And there are obviously a number of manufacturers. Barclay Homes have actually been setting up their own factory. The managing director who's doing that used to run the manufacturing facility for Unite, which produced volumetric student accommodation. So I think there are clear indications in the marketplace that modular is gaining ground over traditional.
Thanks, Ken. So the next question, do you see steel construction is overtaking timber?
For buildings in certain areas, yes, because of the change to the building regulations. Certainly cross-laminated timber is diminishing. It was gaining ground up until obviously a couple of years ago. But the hybrids, the cross-laminated timber manufacturers are in discussion with light gauge steel manufacturers to design hybrids where the internal structure could still be timber, but the facade would be light gauge steel with non-combustible materials and finishes. And then there are limits to what timber can actually achieve. If it's say milled timber, probably 5-6 stories, because of the inherent characteristics, the timber will shrink, and if you go too high with just normal milled timber, you'll get quite a bit significant shrinkage and compression. I've been in one building which was 4 stories timber, and the stair shaft was actually traditional construction, and they ended up with a 25mm step down into the modules from the stairwell, simply because of the characteristics of the timber material. And in other countries, interestingly, for example, in Norway, they're up to 50 stories. Not 50 meters, sorry, not 50 stories, 50 meters in timber. Same in British Columbia. If you actually follow the Timber Journal and the developments in the West Coast of USA and Canada, where timber is plentiful, regulations are being rewritten, and there's far more construction going ahead. In terms of steel, there's been I think an uplift in the uptake on light gauge steel as opposed to hot rolled. But again, that light gauge steel has its limitations. I think I can't remember exactly what the exact maximum height is, but even even modular, the example I gave in Croydon, the 40 stories, the central towers are actually slip cast concrete to provide lateral stability, and then the modules are then stacked but tied back, such that you simply cannot build modular on its own without some sort of core structure. Although that core structure could just as easily be steel, obviously hot rolled steel. So steel, I think it's a case of what's best for your particular project.
The next question is, there is a reputation that the value of modular houses depreciates over time compared to the conventional homes. Do you agree?
It's not something I've looked at, but I can understand. But I think it's perception, and it's a bit like the car market. There are perceived. There's a perceived value about some models, and it doesn't surprise me if that is actually happening.
Okay, the last question that we've got here, so please do add any more if you have any, is we've seen a load of foreign investment into the modular MMC sector, but many companies, mainly on the residential sector, even with huge investment, are struggling to gain traction. How can product manufacturers help support the OSM companies?
Need to have a bit of think about this. Yes, there is the foreign investment seems to be gaining traction because of the publicity that's going on. Because we've got IKEA and then we've got Sekisui from Japan. To be honest, I'm not really sure how best to get access to market, unless it's a case of a symposium or an expo of some kind purely focused on modular residential developments as a showcase of different products. Or do you go to something like MIPIM, which is obviously the developers forum, or I'm trying to remember what there's a major housing expo in Manchester every year. I can't remember offhand exactly what its title is. I've actually been to it a couple of times. I think one of the modular manufacturers actually did a demonstration house outside the exhibition a couple of years ago. I think which they built it in 2 days. And the surprising thing, or not the surprising, the disappointing thing is the same thing has been happening for such a long time, because I can remember a modular manufacturer doing a demonstration project in Linlithgow to the west of Edinburgh, probably back in either in the late 80s or the early 90s, where they built 2 semi-detached houses in the space of 48 hours. But there seems to be this reluctance to fully commit, and it may well be related to the previous problem, that there's this perception that a modular home is basically the Mini, whereas something traditional is the Rolls Royce, which is false perception, because the quality and the materials and the finishes, etc., in a modular building are just exactly the same as they would be for traditional construction.
The next question is, what challenges, if any, do manufacturers face in introducing new products into the design of residential builds?
Most contractors, most builders like to be second to be first. They don't want to take the risk of prototypes and new materials without seeing them fully tested and used elsewhere. So somebody else can take the risk and they'll be the second people because somebody else has already taken the risks.
So there's a question here around insurance and timber frames. So how will we be affected, and will the modular timber buildings and frames for insurance companies? So I think that question is doesn't quite make sense.
It's okay. The Dalston Works, which I showed as an example, the owners of the flats in that particular development cannot get insurance, and they cannot sell to anyone who doesn't want to pay cash, because the mortgage lenders will no longer offer mortgages on that particular building because the construction. So the issue would be timber buildings greater than 18 metres in height, or buildings with timber or flammable materials in the exterior facade greater than 18 metres in height. So there is a big concern. There should be no issue for low-rise timber. There are concerns given recent fires, but that always seems to be the case. And yet, if you look at the performance, certainly of engineered timber, Trada did a report on a laboratory for Nottingham University, which actually burned down about 2 to 3 weeks before it was due to be handed over. And what they found is that the timber structure, which I think in that case was glulam, actually stood for something like 11 to 12 hours. If that had been a steel structure, the steel would have melted and the whole entire thing would have come down. So in some cases, timber structure is actually safer than steel.
Okay, I think that's all the questions that we have for now. If you do have any other questions, please email either Ken, myself, or the school. So thank you, Ken, very much, and thank you everyone for joining. There's a short feedback form that will take about 2 minutes of your time, and we'd be really grateful if you could answer that. Otherwise, thank you again for joining, and we hope to see you again soon.
Thanks everyone for listening this afternoon.